video, we will be learning about the integration of the partial fractions of different forms. Then, degree of denominator. This is the first and foremost condition for the partial fractions. So you will form the partial fraction only when this condition is fulfilled. If such a situation is not there, then you first reduce the degree and then you apply the partial fraction. In the second category, we have px plus q upon x minus a whole squared, where we have the power 2 of the same number, same value. Then what you will do, you will just write the first form as x minus a and the second form as x minus a whole squared. So this is the partial fraction form for this category. One more category we have where we have any equation px squared plus qx plus r. And here I am having three factors, but all of these are different. In this, first of all, this condition is satisfied where degree is 2 in numerator and degree is 3 in denominator. So when this condition is satisfied and we are having three different factors, so we can easily make the partial fraction in this form. A upon x minus a, b upon x minus b, and c upon x minus c. Now the fourth category where we have px square plus qx plus r upon square of one factor and another value only single. So here also we are having factors in the denominator. So it will be a upon x minus a, the same rule which was applied here in point number 2, plus b upon x minus a whole square plus c upon x minus b. So we have to first learn these categorization of the different forms where we have to form the partial fraction. One more form we have px square plus qx plus r divided by x minus a into quadratic form x square plus bx plus c. This we know that partial fraction is applied only when we have factors in the denominator. Once we know that there are factors in the denominator, we will check the degree of numerator, whether it is less than degree of denominator or not. Here, if I check the degree of numerator is 2 and degree of denominator is 3. So that means I can apply partial fraction here. For such a situation, the rule is, this is same, a upon x minus a, but for this, it is a quadratic equation and I do not have factors for this. I cannot cut it to different factors. So what I will do, I will take the linear equation in numerator and then I will take this quadratic form in the denominator. So these are different forms of partial fraction. The thing which you must remember before applying the partial fraction is that there should be factors in the denominator. And second thing, when there are factors, degree of numerator should be less than degree of denominator. So let us now start with the exercise. In this question, we have two factors in the denominator. That means it is very clear that we can apply the partial fraction. So to apply the partial fraction, this is the very first form which I have just discussed before the exercise. So the partial fraction will be very simple. A upon first factor plus b upon second factor. Now here, the very important step, I will take the LCM. So after taking the LCM, denominator is going to be same. And it will be a into x plus 2 plus b into x plus 1. So this term and this term will cancel out. So you can directly write without writing the denominator this step. So it is a into x plus 2 plus b into x plus 1. Now after this, we have to find the values of a and b. So the very simple thing which I am going to tell you here is, first put this factor equals to 0. When I put x plus 1 equals to 0, I will get x is equals to minus 1, right? So put x is equals to minus 1 in this equation. So when I will put x is equals to minus 1, this side only x, so minus 1. Here minus 1 plus 2 is 1. And if I put x is equals to minus 1, this will become 0. So directly I will get the value of a as minus 1. Similarly, from the next factor, by putting x plus 2 is equals to 0, I will get x is equals to minus 2. Now I will put x is equals to minus 2 in equation number 1 again. So this is minus 2. If I will put x is equals to minus 2 here, it will become 0. And if I put x is equals to minus 2 here, it will become this. And minus will cancel. The value of b comes out to be 2. Now let us convert the question. Minus dx divided by x plus 1 plus b is 2 integral dx divided by x plus 2. I have taken the constant outside, right? And here like this. Now integration of minus we can take outside, that is not the problem. Integration of 1 upon x plus 1 is minus log x plus 1 and plus 2 log x plus 2. Since this is indefinite integral, so constant of integration will come here. Now we know the property of log, that m log of n. This is log n raised to the power m. Similarly, we have done one more property, log a minus log b. This is log a upon b. So to simplify it, we will use these two properties of log here. So it will be log x plus 2 whole square minus log x plus 1 plus c. So this will be log x plus 2 whole square upon x plus 1 plus c. That is our answer for this question. Sometimes we are not given the factors directly, but we can convert our question in the form of factors like this: x minus 3 into x plus 3. We know a square minus b square, that is a minus b into a plus b. Now the partial fraction, because denominator में factors है, तो partial fraction बनेगा x minus 3 x plus 3. So the partial fraction will be very simple, a upon x minus 3 plus b upon x plus 3. This is the partial fraction. Now on taking the LCM, so this will be x minus 3 into x plus 3. This term will become as it is, and here the factors, x minus 3 into x plus 3. This value is a into x plus 3 plus b into x minus 3. Now this term and this term will cancel. So again the same thing, we have to find the value of x from here and from here. When I put x minus 3 0, I will get x is equals to 3. When I put x plus 3 0, I will get x is equals to minus 3. So in equation number 1, if I put x is equals to 3, this side there is no x, so 1 ho gaya. If I put x is equals to 3, then it will be 6 and this term will be 0. So the value of a comes out to be 1 upon 6. Similarly, when I put x is equals to minus 3, this value will become 0 and the value here will be minus 6. So the value of b is minus 1 upon 6. Once I get the values of a and b, I will integrate it. Forget about the question, whatever was there in the question. Go here, integrate it simply by putting the values. The value of a is 1 by 6 constant. I'm taking outside, and this is dx upon x minus 3. Minus 1 by 6 integral dx upon x plus 3. So when I integrate, I know the integration of 1 upon x minus 3 is log of x minus 3 minus 1 upon 6 log of x plus 3 plus c. So applying the property of log a minus log b is log a upon में b plus c. This is the answer. In this question, we have 3 factors in the denominator. That means it is very clear that we will apply the partial fraction. So let us have the partial fraction here, which will be very simple as I have 3 different factors here. So it will be a upon first factor plus b upon second factor plus c upon third factor, like this. Now I will take the LCM. Here in this situation, take the LCM very carefully. Denominator is going to cancel whether you write it or not. That is completely your choice. So here also the LCM is going to be same, like this. Now if I take a, then with a I will have 2 values, whatever is not there in the denominator of a, x minus 2 into x minus 3. This is a very simple way to take the LCM. Then when I take b, so I will take these 2 values. So it will be x minus 1 into x minus 3. When I take c, I will take these 2 values, x minus 1 into x minus 2. Very simple. Now this and this is going to cancel, not an issue. Now what I will take the values of x from here, and from here. When I take x minus 1 as 0, I will take x as 1. When I take x minus 2 as 0, I will get x as 2. When I will take x minus 3 as 0, I will get x as 3. This is very simple way to find the values of a, b and c. So I will put these values in this equation. So when I put x as 1, so if I put x as 1 here, this will become 2. When I put x as 1 here, 1 minus 2 minus 1, 1 minus 3 minus 2. And here if I put x as 1, this will become 0. When I put x as 1, this will also become 0. So no need to put anything. So 2 is equals to 2 into a, and I will get a as 1. Then next I put x is equals to 2. So here if I put x is equals to 2, so the value will be 6 minus 1, that means 5. So here with a it will going to be 0. With b, 2 minus 1, 1 हो गया. 2 minus 3, minus 1 हो गया. And here it will be 0. So the value of b comes out to be minus 5. So I got a, I got b, then I will find out c. I put x is equals to 3. 9 minus 1 is 8. If I put x as 3, the value of with a becomes 0. The value with b will become 0, and the value with c, it will be 3 minus 1 2 and 3 minus 2 1. So the value of c comes out to be 4. So I got all 3 values. So my answer will be, I will just integrate after putting the values here. So if a is 1, so this will be integral dx upon x minus 1. Then b is minus 5 integral dx upon x minus 2. C is 4 integral dx upon x minus 3. So integration is very simple. Log of x minus 1 minus 5 log of x minus 2 plus 4 log of x minus 3 plus c. Now log a plus log b minus log c. आप इसकी प्रॉपर्टीज चाहें तो लगा सकते हैं, नहीं तो आंसर यहीं छोड़ सकते हैं. मैं आपको लगा के बता देती हूँ. log x minus 1 into x minus 3 power 4. मैंने दो प्रॉपर्टीज लगाई हैं, इस 4 को पावर में भेजा और इन दोनों में log a प्लस log b लगा दिया, फिर माइनस log x माइनस 2 पावर में 5 प्लस में c. So again log a minus log b will be log x minus 1 x minus 3 power 4 divided by x minus 2 power में 5 plus c. If you wish, you can come up to here. Otherwise, this may be the final answer. In this question, we have the term x square plus 3x plus 2 in the denominator. So here one thing comes to my mind, that whether can I apply the formula of integral x square minus dx upon x square minus a square or not. Whenever we can have factors in the denominator, we always apply partial fraction, because first it is a rational function, right? So let us just find out whether it can be converted into factors or not. By middle term splitting, I can easily have 3x as 2x plus x like this, and then I can have x plus 2, x is common, plus 1 into x plus 2 into dx. So this is now converted to this, x plus 1 into x plus 2 into dx. So iska partial fraction, because only two factors I have in the denominator. So we can have the very easy partial fraction, a upon first factor plus b upon second factor, like this. Now on taking the LCM, this will be 2x upon x plus 1 into x plus 2. This side, if I take the LCM, denominator is definitely going to be same on both the sides. It will be a into x plus 2 plus b into x plus 1. This term and this term is going to cancel out. So I have, now what I will do, as we were doing earlier, put x plus 1 0, I will get x is equals to minus 1. Put x plus 2 0, I will get x is equals to minus 2. So after putting this in this equation, if I put x as minus 1, this side will be minus 2. And this side will be minus 1 plus 2 will be 1. And that with b will become 0. So a comes out to be minus 2. Then if I put x is equals to minus 2, so this side will become minus 4. And this value will become 0. And minus 2 plus 1 is minus b. So the value of b comes out to be 4. Now when I have these two values of a and b, I will put these values here and integrate. So the value of a is minus 2 integral dx upon x plus 1 plus 4 integral dx upon x plus 2. Now simple integration, minus 2 log x plus 1 plus 4 log x plus 2 plus c. Now we can have the property of log. What we can take 2 as the power. Similarly, here I can take 4 as the power plus c. Log a minus log b. This is log x plus 2 power 4 upon x plus 1 square plus c. So you can write up to here also. Otherwise, this is your final. In this question, this is very clear that we have factors in denominator. But the thing is that here degree of numerator is 2 and degree of denominator is also 2. In such cases, we cannot take partial fraction directly, right? So what we do, we divide the numerator with denominator. But before dividing, rule is that we take the terms in the form of decreasing powers. That means minus 2x square will come first. I'm multiplying these two. Minus 2x square will come first plus x. Similarly here, minus x square plus 1. This is a rule, right? So when we are dividing this term with this term. So I will get half. So half, I multiply with half these two terms. So this value will become minus x square plus x by 2. On subtracting this term will cancel and it will be 1 minus x by 2. We cannot divide it further. We know the division algorithm. Division algorithm, dividend. Dividend is equals to divisor. Divisor is this into quotient plus remainder. Right? Dividend is equals to divisor. This is the dividend I have taken. Dividend. This is the divisor I have taken into quotient plus my remainder. So all this I have taken here. Now what I will do, I will replace the numerator with the term whatever I got here. So it will be x into 1 minus 2x into half plus 1 minus x by 2, the next term, divided by x into 1 minus 2x into dx. Now, splitting the numerator. On splitting the numerator, here in this term and this term is common. So, I am left with only half. Half I am taking outside dx. Plus, now the next term, 1 minus x by 2. Here, I am taking the LCM directly. If I take the LCM, this will be 2 minus x. And this half I am taking outside. And this is x into 1 minus 2x. I hope this step is clear. Now, this is half integral dx. So, this will be x by 2. And next term, this term I am calling as I1. I will integrate it separately and put my answer here, right? So, let us now integrate 2 minus x upon x into 1 minus 2x. Now, you must have observed that in numerator, we have degree 1, in denominator, we have degree 2. That means it is perfectly ready for the partial fraction to be taken. So partial fraction will be very simple in this case. 2 minus x upon x into 1 minus 2x. Very simple partial fraction as I have two factors only here. So it will be b upon 1 minus 2x. Now the next step will be definitely to take the LCM. So when I will take the LCM, this side will remain the same. And this will be a into 1 minus 2x plus b into x upon x into 1 minus 2x. This term and this term will cancel. So I have, now what I will do, I will put x is equals to 0. So definitely I am going to get x as 0. If I put this as 0, I am going to get x as half. Right? Now I'm putting here in this equation number b. If I put x as 0, this side is 2. If I put x as 0, this will be a and that will be 0. Right? So directly by putting x as 0, I'm getting a is equals to 2. If I put x as half in equation number b, so 2 minus half. Let me just write down 2 minus half. If I put x as half, this value will become 0. So I'm not putting. And if I put x as half, this value is b into half. So 2 minus half is 3 by 2 definitely. And this is b by 2. So the value of b comes out to be 3. So I get b also. I got a also. Now I will just integrate by putting the values over here. So 2 integral dx upon my x plus 3 integral dx upon 1 minus 2x. Now 2, this is the value of I1 I am finding by now. So I1 is equals to this value. So 2 log of x plus 3. Here take the integration very carefully because 1 upon 1 minus 2x, it is definitely log of 1 minus 2x. But here you have to divide with the derivative of 1 minus 2x. Because derivative of 1 minus 2x is minus 2 plus c. So c will be taking in the final step. So no need to take it here. So now this is equation number c. And this is definitely the value of I1. Now putting the value of I1 in equation number a, I will get the final answer. So it will be x by 2 plus 1 by 2 into I1. This is 2 log of x minus 3 by 2 log of 1 minus 2x plus c. This is our answer for this question. In this step, I can see I have two factors in the denominator. Let us see the type of partial fraction we can take here. X square plus 1 into x minus 1. So here, this is the quadratic equation. So I told you already, whenever we have quadratic equation, we have linear equation in the numerator divided by the quadratic. This is how we take the partial fraction in this case. Plus, we have the linear. So I will take c upon x minus 1. अब तक हमें इतना तो समझ आ ही गया है कि जितनी डिग्री डिनोमिनेटर की होती है हमारे पार्शियल फ्रैक्शन में उतने ही कांस्टेंट होते हैं. यहाँ डिग्री 3 है डिनोमिनेटर की तो कांस्टेंट भी 3 है. अगर डिनोमिनेटर में डिग्री 2 है तो न्यूमरेटर में डिग्री 1 होती है. नाउ ऑन टेकिंग द एलसीएम, सो इट विल बी ax plus b put inside the bracket when we have two terms always into x minus 1 plus c into x square plus 1. Here I have taken the LCM, nothing else, like this. This is not mandatory to write if you understand, because this and this is going to cancel. So not mandatory to write every time the denominator in this step. Now, if I put here, one thing is very important. If I put x square plus 1 as 0, see, I will get x square is equals to minus 1. I will get x square is equals to minus 1, which is not a valid value, which is not possible. So we can't take it, right? So what we do, if I put x is equals to minus 1, I will get x is equals to 1. So let us first put x is equals to 1. At least we have something. If I put x is equals to 1 in equation A, this is 1. If I put x is equals to 1, it will be 0. Drop it. C into 1 plus 1, it will be 2. So I get value of C as half. Now what to do? अब तो values रखने के लिए बची नहीं है, तो अब हम अपनी मर्जी से values रखेंगे. And we will try to keep the easy most values. Suppose x is equals to 0, most easiest form of value. If I put x is equals to 0, this is 0. If I put x is equals to 0 here, so it will be a into 0 means 0 plus b into 0 minus 1, that means minus 1, plus c into 0 plus 1 means 1. So I have one relation, minus b plus c is equals to 0, which will be used later on. Let us take one more value, suppose minus 1, because 1 I have taken already, so I am taking minus 1. If I put x is equals to minus 1, fine, and this will be minus a plus b. Minus 1 is minus 2 plus c minus 1 square, that means 1 plus 1. So the value is minus 2 minus minus plus 2a minus 2b plus 2c, right? And from here we can easily get b is equals to c. So c is equals to half, so b is also half. So here we get b also as half. So putting the values, 2a minus 2b is half plus c is also half, right? So this and this cancel, this and this cancel. So minus 1 is equals to 2a, because these terms are going to cancel automatically. So the value of a comes out to be minus half. So we get all the values. Now we will put all these values here and then integrate. So if I take a as minus half into x plus b, b is half, upon x square plus 1 dx plus c, c is half integral dx upon x minus 1. So this is what we have here. Now minus half is common here. We can see easily minus half is common here. Half is common. In fact, half is common. So this is minus x plus 1 upon x square plus 1 dx. plus half integral dx upon x minus 1. Here we can split the numerator into two parts. So it will be half integral minus x dx upon x square plus 1 plus integral dx upon x square plus 1 plus half integral dx upon x minus 1. Now, if we take the integration, here x square plus 1 can be substituted as t. So if I take x square plus 1 as t and differentiate it using substitution method, so I will get 2x dx as dt. But the problem is here I'm not having 2. So what I will do, x dx is dt upon 2. So I will go to question. Replace x dx with dt upon 2. 2 I'm taking outside, minus dt upon t. Plus integration of dx, this is tan inverse x, the direct formula, plus half log x minus 1 plus c. So 1 by 2 will become 1 by 4 minus log t plus tan inverse x upon 2 plus half log x minus 1 plus c. Now we will put the value of t. So answer will be minus 1 by 4 log x square plus 1 plus tan inverse x upon में 2 plus half log x minus 1 plus c. That is the answer. In this question, I have again factors in the denominator. So we can apply the partial fraction here. So it is a upon x minus 1 whole square into x plus 2. So here in this situation, the partial fraction rule number 2, a upon x minus 1, जिसका स्क्वायर होता है, पहले उसको सिंगल लेते हैं, फिर b upon x minus 1 का स्क्वायर like this plus c upon x plus 2. Now we will take the LCM here, x minus 1 square into x plus 2. So this is x. Here the LCM will be same, x minus 1 square into x plus 2. So here when we will take this, तो a के साथ अब इसको इससे डिवाइड करेंगे तो it will be only x minus 1 into x plus 2. Then with b it will be only x plus 2, and with c it will be only x minus 1 square. Now this and this are going to cancel. Now if I put this as 0, I will get x is equals to 1. If I put this as 0, again I will get x is equals to 1. If I put this as 0, I will get x is equals to minus 2. Let us now put this in equation number A. Now if I put x as 1, this is fine. If I put x as 1, this will be 0. So I am not putting. So 1 plus 2 will be 3. Plus if I put here 1, it will again be 0. So this implies the value of b is 1 by 3. Then if I put x is equals to minus 2, this will be minus 2. This will become 0. This will also become 0. And here c into minus 2 minus 1 minus 3 whole square. So minus 2 is equals to 9c. So the value of c is minus 2 by 9. This is the value of c. 0. If I put x is equals to 0, this side will become 0. If I put x is equals to 0, it is minus 1 into 2. If I put x is equals to 0 here, it will be this, and it will be c only. So I have the values of b and c. This is minus 2a plus 1 by 3 into 2 minus 2 by 9. So this will be 2a equal 2/3 minus 2/9. आप देख रहे हो सब में 2 है, तो मैंने काट के इसको 1 कर दिया. So the value of A now will be, taking LCM as 9, so it will be 2/9. So now putting these values of A, B and C here in this equation. So on integration, it will become A is 2/9 outside, integral dx upon x minus 1 plus 1/3 integral dx upon x minus 1 whole square minus 2/9 integral dx upon x plus 2. Now 2/9 log x minus 1. Integration of 1 upon x minus 1 is log x minus 1 plus 1/3. When there is square, we do not take log. I am taking it to the power. This. Then I will apply power rule in the next step. 2/9 log x plus 2 plus c. So this will be 2/9 log x minus 1. Now here I will apply the power rule. So the power rule is what? X minus 1. The power is increased to 1. So minus 2 plus 1. It will be minus 1 divided with minus 1. Minus 2/9 log x plus 2 plus c. So this value will be, देखो ये और ये like terms हैं, तो 2/9 I can take common and this will be log a minus log b, x minus 1 upon x plus 2 minus 1/3 into x minus 1 plus c. This is minus 1. X minus 1 plus c. That is answer. Here in this question, I do not have the factor directly, but I can convert to the factor. So this is 3x plus 5 divided by, from the first two term, x square is common. So it will be x minus 1. From next two term, minus 1 is common. It will be x minus 1. So it was not looking like कि यहाँ पर denominator में factors हैं, but once we have taken common, so we got the factors. So x minus 1 into x square minus 1 into dx. Now I have the factors. So let us just simplify it. Now x square minus 1 can be written as x minus 1 into x plus 1, like this. So it may be written as 3x plus 5 upon whole square of x minus 1 into x plus 1 into dx. Now let us have the partial fraction here. This is x minus 1 square x plus 1. So the partial fraction is going to be a upon x minus 1, b upon x minus 1 whole square plus c upon x plus 1. So take the LCM very carefully in this step. This is 3x plus 5. Denominator is going to be same. And here also. Now the LCM. So a into x minus 1 into x plus 1. B into x plus 1. C into x minus 1 ka square. This and this going to be cancelled. Now, if I put this as 0, I will get x as 1. If I put this as 0, so no different value. If I put this as 0, I will get x as minus 1. So let us now first put x is equals to 1. So it will be 8. If I put x is equals to 1 here, this will be 0. If I put x is equals to 1 here, this is also 0. So here it will be 2b. So the value of b comes out to be 4. Here I got b. If I put x is equals to minus 1, so this value will be 2. If I put x is equals to minus 1, this is going to be 0. If I put x is equals to minus 1, this is again going to be 0. And if I put x is equals to minus 1 with c, so minus 2 ka square. So I will get C as 1/2. B and C आ गया. एक और simple value put कर लेते हैं. X is equals to 0. So this side will become 5. On putting X is equals to 0. So A will be A into 0 minus 1 minus 1, 0 plus 1 plus 1. B into में 1 and C into में 0 minus 1, that means 1. So 5 is equals to minus A plus B plus C. So 5 is equals to minus A, we don't have, B is 4 and C is half. So the value of A comes out to be 4 plus half, that will be 9/2 minus 5. So A comes out to be minus half. This is the value of A. Now putting A, B and C in here. Now A is minus half, so minus half integral dx upon x minus 1. B is 4, so 4 integral dx upon x minus 1 square. C is half, so half integral dx upon x plus 1. So this is integration of this is log of x minus 1. This is 4. देखो इसमें पावर रूल लगेगा. x minus 1 की पावर -2 है, तो -2 में जब हम +1 करेंगे, this will be -1 divided by -1 plus half log x plus 1 plus c. Now this term and this term is like term, so log की property लगा देते हैं. log x plus 1 upon x minus 1 minus 4 upon x minus 1 plus c. This is the answer for this question. In this question, if I see the degree of numerator is 3 and degree of denominator is 2, but partial fraction में तो ऐसा नहीं होता, उसकी degree less होनी चाहिए. That means we have to divide. Secondly, x square minus 1 के factors बन रहे हैं, so we are going for partial fraction here. So let us first divide with x square minus 1. In this question, if I divide x cube with x square, so this value will be x. So x into x, x cube minus x. Now if I subtract, this will be plus, this is cancel, this is 2x plus 1. Now dividend is equals to divisor into quotient plus remainder. So we will replace the numerator with this term, 1 into x plus 2x plus 1, like this, divided with x square minus 1 dx. Now we will split the numerator. Numerator को split कर देते हैं. So this and this will cancel. This will be only x into dx. And this term will be 2x plus 1 upon x square minus 1 dx. इसका इंटीग्रेशन तो हमें पता ही है कि x square upon 2 हो जाएगा. Here we have the factors 2x plus 1 upon x minus 1 into x plus 1 dx. तो इसके लिए हमें पार्शियल फ्रैक्शन करना पड़ेगा, तो हम इसका पार्शियल फ्रैक्शन कर लेते हैं. 2 फैक्टर्स हैं, तो पार्शियल फ्रैक्शन इज वेरी इजी. a upon x minus 1, b upon x plus 1. So this will be 2x plus 1, simple LCM, a into x plus 1, b into x minus 1. जो LCM है वो तो हमारा ऑलरेडी कैंसिल हो जाता है. So if you will not write, that is also okay. Now if I put x minus 1 as 0, I will get x as 1. If I put x plus 1 as 0, I will get x as minus 1. So if I put x as 1 here, so this will be 2 plus 1, that means 3, and this will be 2a. So the value of a comes out to be 3/2, like this. If I put x as minus 1 here, so this value will be minus 1, this value will be 0, and this value will be minus 2b. So I get the value of b as half. A और B दोनों values आ गई. So now here we will put and integrate. So A is 3/2 इंटीग्रल dx upon x minus 1 plus 1 by 2 integral dx upon x plus 1. So this is 3 by 2 integration is log x minus 1 plus 1 by 2 log x plus 1. So this is the integration. So we will put the value of this integral here. This is suppose equation number 1. So first equation में जब हम put करेंगे x square upon 2 plus 3 by 2 log x minus 1 plus half log x plus 1 plus c. That is the answer. In this question, we can write x power 4 minus 1 as x square minus 1. A square minus b square. That is a minus b into a plus b. Like this. So, this can be written as dx upon x minus 1. X square minus 1 I am writing again as a minus b, a plus b and x square plus 1 like this. So this is the product of three factors. So here partial fraction we will be taking as 1 upon x minus 1, x plus 1 and x square plus 1. So here the partial fraction is a upon first factor, b upon second factor प्लस c अपॉन मतलब c नहीं आएगा यहाँ पर cx प्लस d आएगा क्योंकि नीचे क्वाड्रेटिक है. रिमेंबर दिस ऑलवेज. नाउ इन नेक्स्ट स्टेप वी विल बी टेकिंग द एलसीएम like this, and here the LCM is x minus 1, x plus 1, x square plus 1. So the product with a, it will be x plus 1 into x square plus 1, and the product with b, it will be x minus 1 into x square plus 1, and the product with cx plus d, it will be x square minus 1. दोनों का product ले लिया x square minus 1. Now this and this are cancelled. So if I put x minus 1 as 0, I will get x is equals to 1. So if I put x is equals to 1, this will be a into 2 into 2. This will be 0 and this will also be 0. So the value of a comes out to be 1 by 4. Okay. If I put this as 0, I will get x as minus 1. So this is 1. If I put x as, this will be 0. If I put x as minus 1, this value will be b into minus 2, 2. And x is 1, this value will be 0. So the value of b is also minus 1 by 4. Third value I am not getting because I am getting x square as minus 1. So I will put x is equals to 0. That is the easy most value we can have. So I am putting x is equals to 0 here. So this is 1. This will be a into 0 plus 1, 1, 0 plus 1, 1. Plus b into minus 1, 0 plus 1 is 1. Plus c into 0 means 0. Only d will be left here. 0 minus 1 is minus 1. So 1 is equals to a minus b minus d. I am having a and b. Therefore, I will get the value 1 is equals to 1 by 4 plus 1 by 4 minus d. So the value of d is 1 by 2 minus 1. So d comes out to be minus half. d भी आ गया, but अभी एक और वैल्यू रहती है, c की वैल्यू रहती है. तो हमने 1 पुट कर लिया, minus 1 पुट कर लिया, 0 पुट कर लिया. अब हम x को 2 पुट करेंगे. This side only will be 1. If I put x as 2, let us write carefully. 2 plus 1, 3. 2 का square, मतलब 4 plus 1, 5. Plus b. 2 minus 1 is 1. And 2 का square, मतलब 4 plus 1 means 5. Plus 2c plus d. हमने x को 2 पुट किया. और 2 का square 4 minus 1 is 3. ठीक है. अब हम क्या करेंगे, जो वैल्यूज हैं 1 is equals to 15 into a आपका 1 by 4 है. This will be 15 by 4. B भी हमने -1/4 निकाला है, so it is -5 by 4. D आपका -1/2 है, so 2C -1/2 into में 3. अब देखो 15 - 5 10 by 4 हो गया, so 1 - 10 by 4. 1 - 10 by 4, it will be 2C -1/2 into में 3. So it will be -6 by 4. This side -6 by 4. This is 2C -1/2 into में 3. 3 and 6 will cancel. This will be -2 and this will be -1/2. So 2C -1/2 इधर है और इधर से +1/2 गया, तो the value of 2C is 0. This gives C as 0. So we got all the values of A, B, C and D. Bit complicated, but अगर समझ नहीं आए थोड़ा सा एक बार रिवाइंड कर लीजिए. I think that must be clear to you. Now putting the values of A, B, C, D here to integrate. So if I put the value of A as 1/4, this will become 1/4 integral dx upon x minus 1. D is -1/4 integral dx upon x plus 1. Then Cx plus D. C तो आपका 0 है, तो D is -1/2. So it will be -1/2 dx upon x square plus 1. So this is 1/4 log of x minus 1 minus 1/4 log of x plus 1 minus 1/2 tan inverse x plus c. This is 1/4 log of x minus 1 upon x plus 1, like this, minus half tan inverse x plus c. This is the answer. This is a question of partial fraction, but here new type of problem arises because here degree is very high, which is n plus 1. So we have learned the degrees up to 4. But what to do in these questions? These questions are very simple. Just substitution is required and then we will be doing partial fraction here. Let us see this question. Let us assume that x power n plus 1 as t, and whatever we substitute, we differentiate. The derivative of x power n is n x power n minus 1 into dx is equals to dt. But I have dx here in numerator. This is dt upon n into x power n minus 1. This is a very simple trick for these questions. As we have product in the denominator, it is clear that we have to apply the partial fraction. But we have to reduce the degree as well. To reduce the degree, I have substituted. Then I will go back to my question and I am replacing dx with dt upon n. N is a constant value I am keeping outside. It is x power n minus 1. And the terms which were here, already I am taking them as it is. Then before integrating, my all x should be converted in the form of t. So here, see, here base is same. So powers are going to be added, n minus 1 plus 1 into x power n plus 1. So this is 1 by n integral dt. 1 and 1 will cancel. This is x power n into x power n plus 1. So this is 1 by n. This is integral replaced with t. X power n will be replaced with t minus 1. Now we can solve this question by partial fraction. So partial fraction will be simple, 1 upon t minus 1 into t. The first fraction will be a upon t minus 1. Second fraction will be b upon t. So it is 1 upon t minus 1 into t. And this is a into t plus b into t minus 1 upon t minus 1 into t. This term and this term will cancel. So when I put t minus 1 as 0, I will get t as 1. When I get t as 0, I will get t as 0. So when t minus 1 is equals to 0, it gives t as 1. So if I am putting t as 1 in equation number A, so here is 1, this is A, and so value of A comes out to be 1. If I put t as 0, so here this side it is 1, A into 0 is 0, B into 0 minus 1 is minus 1. So the value of B comes out to be minus 1. Now I am putting here and then integrating here. So first 1 by n will be here. Let us not forget it. And this will be dt upon t minus 1. Minus 1 dt upon t. Right? So it is 1 by n log of t minus 1 minus log of t plus c 1 by n log a minus log b log a upon b plus में c. Replace t with x power n plus 1. So answer will be log of. If I replace t with x power n plus 1, it will be x power n upon x power n plus 1 plus c. That is our. In this question, if we see carefully, we can see factors in the denominator, but हमारे पास sin x है और ऊपर हमें cos x दिख गया. तो substitution जिनको अच्छे से आता है, they can guess if I assume sin x as t and if I differentiate, the derivative of sin x is cos x. So I will get cos x dx is equals to dt. So this value is dt upon 1 minus t into 2 minus t. This is now simple partial fraction. So 1 upon 1 minus t into 2 minus t. So partial fraction is a upon 1 minus t plus b upon 2 minus t. So on taking the LCM, it will be a into 2 minus t plus b into 1 minus t. So now if I put this as 0, I will get t as 1. So t as 1. This side is 1. A into 2 minus 1 is 1 and b into 0. So the value of a comes out to be 1. If I put this as 0, I will get t as 2. So this side is 1. 2 minus 2 is 0. B into 1 minus 2 is minus 1. So the value of b comes out to be minus 1. So I get a and b. So we can put here a and b and integrate to find the answer. So here this will be integration dt upon 1 minus t minus 1 minus integral dt upon 2 minus t. Integration of this is 1 upon 1 minus t divided by the derivative. Derivative of 1 minus t is minus 1 minus log of 2 minus t divided by the derivative minus 1 plus c. So this value will be log of 1 minus t minus यहाँ जाएगा plus log of 2 minus t plus c. Log a minus log b is log a upon b plus c. T we can replace with sin x. So 2 minus sin x upon 1 minus sin x plus c. In this question, as we can see, we have factors in the denominator as well as numerator. First thing we can see here is degree is same. बिकॉज डिग्री को हमें सेम नहीं चाहिए, न्यूमरेटर की लेस चाहिए. तो हम सिंप्लीफिकेशन पर्पस के लिए हम क्या करते हैं, एक्स स्क्वायर को वाई से रिप्लेस कर रहे हैं, नॉट सब्स्टिट्यूट. रिमेंबर आई एम रिप्लेसिंग हियर. सो दिस विल बिकम वाई प्लस 1 वाई प्लस 2 अपॉन वाई प्लस 3 इंटू वाई प्लस 4. जब हम इंटीग्रेट करेंगे वापस एक्स में पहुंच जाएंगे. ठीक है. सो इसको जब मैं मल्टीप्लाई करती हूँ, दिस इज वाई स्क्वायर प्लस 3y प्लस 2 एंड दिस इज वाई स्क्वायर प्लस 7y प्लस 12. अब हमें डिग्री सेम करनी है, लेस करनी है न्यूमरेटर की, डिवाइड भी करना है। तो इसका एक बेस्ट वे होता है कि हम क्या करें, न्यूमरेटर की फॉर्म में डिनोमिनेटर की फॉर्म में न्यूमरेटर को ले आते हैं। तो अब हमारा डिनोमिनेटर है y² प्लस 7y, वैसे तो मैंने डिवाइड करना बताया था, लेकिन ऐसे क्वेश्चन में हम ऐसे भी कर सकते हैं, एक और मेथड है y² प्लस 7y प्लस 12, बट मेरे न्यूमरेटर में तो 3y था और मैंने 7y ले लिया, तो बैलेंस करने के लिए हमने 4y कर दिया माइनस, लेकिन हमने 12 था, हमने 2 था, हमने 12 ले लिया, तो हम इसको बैलेंस करने के लिए माइनस कर देते हैं 10। तो हम इसको ऐसे भी कर सकते हैं। अगर मैं ऊपर वाले ब्रैकेट को अब खोलूं तो मुझे वही मिल जाएगा जो मेरे क्वेश्चन में पहले था, y² प्लस 7y प्लस 12 माइनस 4y, 7y माइनस 4y इज 3y, 12 माइनस 10 इज 2, वापस वहीं आ गए। तो हम अपने क्वेश्चन को इस तरीके से भी रिप्लेस कर सकते हैं। क्या किया हमने, पहले न्यूमरेटर लिख लिया, जो एक्स्ट्रा आ गया उसको हमने एडजस्ट कर दिया। नाउ वी कैन स्प्लिट द न्यूमरेटर। जब हम फर्स्ट पार्ट को स्प्लिट करेंगे तो हमें सीधा 1 मिल जाएगा, जब हम सेकेंड पार्ट को स्प्लिट करेंगे तो हमें इस तरीके से फैक्टर्स की फॉर्म में हम रिप्लेस कर सकते हैं। ठीक है, अब हम जब इंटीग्रेट करेंगे y को वापस से x² कर देंगे। अब हम इसमें पार्शियल फ्रैक्शन लगा लेते हैं, इंटीग्रेट बाद में करेंगे। सो 4y प्लस 10 अपॉन y प्लस 3 into y plus 4. Here partial fraction will be very easy. A upon y plus 3, b upon y plus 4. So on taking the LCM, this is 4y plus 10. This is a into y plus 4 plus b into y plus 3. If I put y plus 3 as 0, मुझे y की वैल्यू मिल जाएगी -3. If I put y plus 4 as 0, मुझे y की वैल्यू मिल जाएगी -4. So y की जगह अगर मैंने -3 रखा, -12 plus 10 which is -2. फिर y की जगह मैंने -3 रखा, तो a into 1, वो तो 0 हो ही जाएगा. So the value of a is -2. If I put y as -4, so -16 plus 10, that is -6. -4 plus 4, 0. b into -4 plus 3 is -b. So the value of b comes out to be 6. When we get the values of a and b, we can put these a and b here and we can integrate. अब आप याद कीजिए कि यहाँ पे क्वेश्चन था 1, इंटीग्रेट करते टाइम हमारा y x में कन्वर्ट करना था, माइनस उसके बाद ये टर्म है, तो ब्रैकेट में ले लेते हैं, द वैल्यू ऑफ a इज -2 इंटीग्रल dx अपॉन, मैंने कहा था इंटीग्रेट से पहले y को x² करना है, सो इट इज x² प्लस 3 प्लस 6 इंटीग्रल dx अपॉन x² प्लस 4. वेरी इंपॉर्टेंट स्टेप, आई होप समझ आ गया होगा. मैंने रिप्लेस किया था तो वापस इंटीग्रेशन के टाइम मैंने x में कन्वर्ट कर दिया. नाउ 3 कैन बी रिटन एज √3², 4 कैन बी रिटन एज 2². नाउ हमें पता ही है इंटीग्रेशन dx अपॉन x² प्लस a². दिस इज 1/a tan inverse x by a plus c. This formula I am going to use here. Integration of dx is x, minus minus it will be plus 1 upon a tan inverse x upon a, like this. Then minus 6, 1 upon a tan inverse x upon a plus में c. So my answer is x plus 2 upon √3 tan inverse x upon √3 minus 3 tan inverse x upon 2 plus c. In this question, I can see we have the factors in the denominator, the first thing. Secondly, degree is also less, but at the same time, I can see the derivative of x² is present in the numerator. And if it is so, partial fraction बाद में लगेगा और substitution पहले लगेगा. तो we will assume let x² is equals to t. on differentiating with respect to x, I will get 2x dx as dt. So my question will become dt upon t plus 1 into t plus 3. Simple partial fraction now. 1 upon t plus 1 into t plus 3. So this value is a upon t plus 1 plus b upon t plus 3. Now on taking the LCM, it will be a into t plus 3 plus b into t plus 1. As I said कि values निकालने के लिए इनको 0 करते हैं, तो t will be -1. So a -1 plus 2 is 2, -1 plus 3 is 2, plus b into -1 plus 1 is 0. So the value of a comes out to be half. When I put t plus 3 as 0, I will get t as -3. So a into -3 plus 3 is 0. B into -3 plus 1 is -2. So the value of b comes out to be -half. So we get both a as well as b. Now we will put the values of a and b and integrate here. So it will be half integral dt upon t plus 1 minus half integral dt upon t plus 3. Half dt upon t plus 1 derivative is log t plus 1 minus half log t plus 3 plus c. Half is common. Log a minus log b is log a upon log b plus c. t को हम लिख लेते हैं x square plus 1 x square plus 3 plus c. हमारा क्वेश्चन अगर x में है तो आंसर t में नहीं आएगा. We should remember in this question I can see here factors in the denominator, and I can again split the factors of x power 4 minus 1. But see, there will be 5, degree will be 5, and degree is 5, there will be 5 constant. That will be a hectic task. So if you remember question number 16 of the same exercise, which I've solved earlier in the same video, here I told you when degree is higher and the question is of this form specifically. So in those cases, assume x power 4 minus 1 as t and differentiate it. First substitute and then differentiate. So on differentiating, the derivative of x power 4 is 4x cube into dx is equals to dt. So let us find the value of dx is dt upon 4x cube, right? So we will put the value dt upon 4x cube. तो इसकी वैल्यू हो गई. जो पहले से है उसको बिल्कुल नहीं छोड़ना, उसको एज इट इज लिख दीजिए. नाउ बिफोर इंटीग्रेशन हमारे सारे x कन्वर्ट हो जाने चाहिए t में. कांस्टेंट को मैंने बाहर ले लिया, एंड दिस इज x पावर 4 एंड दिस इज x पावर 4 minus 1. अब x पावर 4 minus 1 को तो हमने t एज्यूम किया था. दिस इज t. x पावर 4 will be t plus 1. Remember, now this is the easy most partial fraction. इसका हम partial fraction कर लेते हैं. So it will be a upon t plus 1 plus b upon t. This is equals to 1 upon t plus 1 into t. Now taking the LCM, it is a into t, b into t plus 1 is equals to 1. So now on putting t is equals to 0, I will get b is equals to 1. On putting t is equals to, यहाँ से निकाल रही हूँ मैं वैल्यू, t को 0, t plus 1 को -1. So it will be minus a is equals to 1. This implies a is equals to -1. a -1 आ गया और b क्या आ गया? 1 आ गया. अब हम इन वैल्यूज को पुट कर देते हैं. a हमारा -1 है, so this is minus dt upon t plus 1. b हमारा 1 है, so this is dt upon में t. So this is minus log t plus 1. 1/4 को हमें भूलना नहीं है. This was outside here. यहाँ पे था ना, -1/4 प्लस log ऑफ t. log a माइनस log b को हम लिख सकते हैं log a अपॉन b. Replace t with x power 4 minus 1. So 1/4 log of x power 4 minus 1 upon x power 4 plus c. That is our answer. This question is not looking like a question of partial fraction, but up till now we do not have any method to integrate it. For this, what I do, first I will do substitution. There are many questions where we do substitution first and then we do partial fraction. So let us assume that e power x minus 1 is equals to t, right? Now on differentiating, I will get e power x into dx is equals to dt. Now, the value of dx may be calculated as dt upon e power x. Go back to the question. Replace dx with dt upon e power x and inside e power x minus 1. Now, we have assumed the e power x minus 1 as t. And the value of e power x will be t plus 1. Right? So, now we can have the partial fraction very easily, which will be a upon t plus 1 plus b upon में t. Now on taking the LCM, this is b. जब दो वैल्यूज होती हैं उनको ब्रैकेट में पुट कर लिया करो, इधर तो 1 है ही. So if you put t as 0, so t is 0, 1 is equals to a into 0, b. So the value of b is 1. If you put t plus 1 as 0, you will get t as minus 1. So 1, so minus a. The value of a is minus 1. Now put a and b and then integrate. A is minus integral dt upon t plus 1. B की value integral dt upon t. This is minus log t plus 1 plus log t plus c. Log a minus log b होता है log a upon b plus c. t की वैल्यू पुट कर देते हैं. t है e power x minus 1. This is the answer for this question. This question is also of the form question number 16. And one more question we have done here. When we have the degree as 3, but the question is of this form, always substitute x square as t or whatever the power of x, higher power of x we assume as t. And then on differentiating, we will get 2x dx as dt. And the value of dx will be dt upon 2x. We will go to the question. Replace dx with dt upon 2x into x square plus 1. 2x into x is x square. This is 1/2 dt upon x square is t. X square plus 1 is t plus 1. Again apply the partial fraction. 1 upon t into t plus 1. A upon t plus b upon t plus 1. So on taking the LCM, it will be a into t plus 1 plus b into t. If I put t as 0, so 1 is equals to a. And if I put t plus 1 as 0, then I will get t as minus 1. So 1 is equals to a into 0 plus b into minus 1. So the value of b comes out to be minus 1 here. Now on integrating, 1/2 is outside. Don't remember, keep 1/2 outside. Putting the value of a as 1, this is dt upon my t integral. Then b as minus 1, dt upon t plus 1. This is 1/2. This is log of t minus log of t plus 1. Log a minus log b, log a upon b plus c. So this is 1/2 log t is x square. So x square upon x square plus 1 plus c. This is the answer.